But we know that nx, ny, number of sections or number of tiles. So number of sections slash tiles. Okay, so that's number of sections slash tiles, nx and ny. To calculate nx and ny, it's just figuring out, how many tiles does VP1 cover. So we could probably do that right here. We could probably inline that right here. So that's rec VP1 dot x1 minus rec VP1 dot x0. Right, because we're gonna try to just assume that the coordinates are properly ordered. So we're going to assume that x1 is always greater than x0. Now, yeah, we're just gonna we're assuming properly formed data. And the next part is we know that if for this edge case here, where the rectangle is all zeros, that there's at least one tile there, right? So we know that 0, 0, well, that equals 0. So we obviously need a +1 there so that we get one tile out of that delta. So we're going to add a 1 to that formula. Okay, so then the number of tiles on the y is the same formula, except we're going to put y's in there, right? So, okay, x's. Okay. So these are the number of tiles that will ultimately be displayed over here, right? But it's the number of tiles that is being selected from this viewport and then displayed over here. So right now, when we're looking at this example here, with these variables here, the number of tiles x and number of tiles y should be 1. There's just only one tile. And I keep on saying number of tiles, and that's why I say I might confuse this with other variables, because we have tx and ty. But it can also be thought of as number of sections, right? Because the number of tiles is 1, and that also means that the number of sections when we're subdividing this is also 1. And if we go down to this example here, the number of tiles is 1, 2, right? Because it's a one-dimensional. I'm looking at one axis, right? So looking at the x-axis, the number of tiles is 1, 2, which means that the number of sections is 1, 2, right? So the number of tiles and the number of sections is the same variable, and that's why I've written sections slash tiles. So nx and ny, you can think of nx as number of tiles or number of sections. Okay, so I think we've figured out a little bit more of the problem. So let's, I'm gonna put a comment here and comment that out, and just make a note that, we're trying to solve Lx and Ly and figure out what that is. So basically, to get the local tile coordinate, all we have to know is what section are you currently in. So what section is the destination pixel currently in as we are iterating over each pixel of the destination viewport. So I'm just going to write down here Lx, Ly is the tile your current destination viewport pixel is currently inside of your dx. Okay. Okay, so with that, how would we figure that out? So without doing any translation, right? Assuming that assuming our map is at, assuming both of our viewports, so assuming both of these viewports are at 0, 0, right? So eliminating some variables. Assuming they're both at 0, 0, how do we figure out which local coordinate of the tile? How do we figure out how these map? So it'd be like something like so it'd be dx. So dx divided by the number of sections x, right? So if we have, well, not divided by number of sections. Okay, yeah, so it wouldn't be like that. It would be, now that we know the number of sections, we need to know the size in pixels of each of these sections in terms of the destination viewport. So for that, we would need to know the destination width and destination height. So I'm gonna take this is VP1. Okay, I'm gonna take VP0 width, and that equals, hold on. So I guess NX and Y can also be thought of as the width of VP1. So do I want to rename this for consistency? I might, but I'm not certain about it. So I'll just make a note here that this is I just want to make a note here. NX equals VP1 width, and then NY equals VP1 height. I just want to be able to see the patterns and the symmetries in the equation to make all the necessary connections. So for VP, for these widths and heights, right, for VP0, right, it's the same formula right here, but we're just using the other rectangle. Okay, and then we'll change that to VP0. And then this one will be VP0 as well. Okay, so minus the x's, add a 1, minus the y's, add a 1, and that's going to give us the width in pixels, and then also the height in pixels. Now that we have that, I'm honestly confused as to why I did that. Number of sections. Oh, okay, yeah, I see why I did that. Okay. So, if we take the entire width of the destination viewport, and we divide it by the number of sections on the X, we're going to get the size of a single tile on the viewport, right? So this one tile, we're going to find that it is 4 by 4 pixels on our destination viewport. And that's going to be important for figuring out the equation down here. So let's do that. And what are we going to call this? So it's kind of like the tile width and tile height. So I know I already have this, so let's see what I define that as. Or maybe I did not. So I'm going to look through my notes really quick, because I'm pretty sure I defined something like that. If I didn't, I have. I'm gonna go backwards. So the tile width, like I want to use a variable called, oh crap, I wasn't recording. I'm gonna stop recording.